All right, physics students, today we are going to be doing the curved mirror lab simulation, and it comes in two parts. The first part is the pre-lab, and basically what it does is it asks you to make predictions on what the images, if there are images, what the images will look like when you place an object in front of a mirror at different locations in relationship to where the mirror is and the focal point. So for number one, we have an object placed beyond the center of curvature, and remember the center of curvature is twice the focal length. So then what kind of, first of all, will it form an image? And then is the image real or virtual? Is it bigger or smaller? Is it upright or inverted? And then it asks about the image location. Will it be beyond the center of curvature? Will it be between F and C? Will it be between F and the mirror? And will it be on the backside of the mirror as a virtual image? Just highlight the answer in each of those pairs that you think is correct, or in this case, the right answer here. There are four more situations, and then you get to the part where you're going to use the simulation. And so this is part two, and what you're going to do is you're going to click on this link and open it up. And you're at the concave and convex mirrors. And so here is our concave mirror. Here is my object, and I can move the object around by clicking on the dot at the top of that arrow and just dragging it to the left and right. I can make it bigger or smaller. I can move the focal point around if I'd like to, move from here to there. For our lab, I said to just leave it at the -4. So you can leave it there. Now, one other thing I would mention is that by convention, we typically say that everything on the front side of a mirror is positive. And for some reason, this simulation has chosen to make all of these objects, or all of these markings negative on the front side, and all the backside markings as being positive. I think they're just using a general Cartesian coordinate system. But I want you to see all of these as being positive and all of these as being negative, and just as far as getting the math to work out. So like I said, you can mess around with that and play around and kind of see what happens to the image as you move the object around. And what you're going to be doing in the lab is you're going to set the object at these different points: 12, 8, 6, 4, and 2. And again, remember, they're on the simulation, it's going to say -12 and -8 and -6. You're going to leave the focal point at 4. And again, the simulation will say -4 for all those. And then I want you to look at those images that are created in the sim and then say, is it real or virtual? Is the magnification bigger or smaller? Is it upright or inverted? Where is it located? Is it beyond C, between C and F, etc.? All right, and then part 3, you're going to practice the math, and you're going to use the mirror equation and the magnification equation for situations 1, 3, and 5. So this first one, the middle one, and the last one. And what I want you to do is I want you to calculate the image distance Q and the magnification for all of those, and then compare those to what the simulation actually gives you. And if you go back to the simulation here, it will give you the object height and the image height. It'll give you the object distance and the image distance, and you can make those calculations and see, do they match up with what you see here?